Because today's a two-parter, we're going to start with the Argan Plane and then hopefully transition into some stuff on modulus. So Argand Plane, very simple. It follows straight from Ruben, some stuff about two-dimensional vectors, and the Cartesian plane. So it's going to be very similar to that. So we're going to sketch these complex numbers on the Cartesian plane. So my first complex number, or my first number is z1 equals 3. Okay, so the real component is 3 and the imaginary component is 0. So what does that look like? It's going to be the line that goes to here. That's going to be z1. Alright, so the real axis is the horizontal axis. The imaginary axis is the vertical. So then we've got minus 2i. So that means there's no real component. The real component is 0. And the imaginary component is minus 2i. So that's going to be z2. We have z3, which has a real component of minus 2 and an imaginary component of positive 3. That's where it's going to end. So this would be the complex number z3. And then part D says the conjugate of z3. So if z3 is minus 2 plus 3i, then the conjugate is going to be minus 2 take 3i, isn't it? We change the positive to a negative in the middle. So that means it's going to go across 2, and now it's got a vertical translation of minus 3. And so that's going to be the conjugate of z3. So that's pretty straightforward, the sketching there on the Argan diagram, and then we'll look at how that's combined with vectors. Okay, in the next question, it says given z equals 2 take I, so this is the question 2 here, z is 2 take I, and w is 1 plus 4i. Okay, find z plus w. First I'm going to sketch z. Z is across 2 and down 1, isn't it? It's 2 take I. That's the complex number z. The complex number w is across 1 and up 4. It has a real component of 1 and an imaginary component of 4. So that's w there. So I've got z and w. And we know from vectors, okay, if we're going to add vectors together, we need to add the tail of the second one to the head of the first one. So it means from this location, I'm going to go across 1 and up 4. Okay, across 1 and up 4 spaces is going to take me to here. Let's sketch that. All right, so that the resultant vector or the resultant complex number is this one here, isn't it? This is z plus w. So I've got z, here's w. Here I've translated w so that the tail of w sits on the head of z, and we're left with z plus w. Okay, so we can sketch it like that using sort of a vector proof. The other way is if we were to go z plus w, well, we can add the real part, which is going to be 3, and the imaginary part, which is going to be 3. Across 3, up 3, that takes us to z plus w. That would be the other way to sketch it. Excellent. Let's get into the Argan Plane.